So children, now let us get started with the second question. So by looking at this diagram, you feel that it is little bit tougher, but no, but it's not tough. It's a simple question. Try to understand the relation. So by looking at this question, object of mass is given hanging from one end of a rod. So hanging from one end of a rod, these cases naturally coming from which chapter? System of particles. In that, the subtopic is about torque. Why? Because if you observe the question carefully, the distances is mentioned here, and in the given question what is saying is the tension, is asking tension, okay, and the mass of this is given as 2 kg, so we can say the other weight is 20 Newton. So here the action and reaction is going between the force and distance. You people know that force into perpendicular distance comes under torque. So that concept is torque, and this is from chapter System of Particles. So like that you have to identify. So first, identification of chapter and its subtopic, naturally formulas. System of particles. Children, don't think that this chapter is tougher. Please don't leave. What I would like to say is that it looks tough, but if you practice, it is easy. System of particles. From this, the subtopic is torque. I hope you know the formula for torque. Torque is nothing but force into perpendicular distance. So perpendicular distance, I am writing it as R perpendicular, okay? So nothing more than that. Now, let me redraw this diagram for you so that you'll understand it easier. What is this? So this is nothing but a rod, uniform rod, okay? So there is an uniform rod of length 1 meter. So let me write this in centimeter. So 1 meter is nothing but 100 centimeter, okay? So we people know that for a given rod, the center of mass acts at the center only. So if it acts at the center, so what I have to do here is that for 100 centimeters, the center is 50 centimeters. So here 50, okay? So the weight acts at the center. So what is the distance from here to here? It is 50 centimeter. Now what is the weight? It's saying that mass is 2 kg. So mass is different from weight, no? So you know that weight W equal to M into G, where M is given as 2 and G you know it as 10. So 20 Newton. So now the weight of the rod is 20 Newton. So step 1 is completed, right? Now read the question again and again. Better take a pause and read it at least 2 to 3 times so that you'll understand it. But don't leave this question. It was really easy question. If you look at this carefully, an object of mass is there 8 kg, which is hanging from one end of the uniform rod. So there is an object of mass 80 kg. So let us consider 80 kg. Read it carefully. What was given is that it is hanging from one end. This part is important. One end. Okay, this end. Like this. What was given is that this is 8 kg. If it is 8 kg, what is its weight? Same as before. Weight formula W is equal to M into G. Okay. So W is equal to M into G. Now the mass is 8. G is 10. So we could write it as 80 Newton. We could write it as 80 Newton. So it is a distance of 100 centimeters. So this point is given as C and this point is given as D. Okay. So question itself has given that pivoted at end C. So that is the reason here I am taking C. Okay, my dear children. Next. Now, there is a cable AB here. So this one we have to look carefully. AB. So here the tension is T. Here the tension is T. So how to find out the force acting on it? So this is T as per the vector of knowledge. So vector is nothing but again junior enter, that is basics, okay? We have to consider it. So if T is there like this, it means it is going upwards towards left side. So one component is left side. Since it is going upwards, other component is in upward direction. So for this tension T, one is in upward direction. Since it is going left side, other component is here left side. Like this I have to write. Okay. Here he has mentioned that this angle is 30 degrees. In such case, this component what you will write? Since it is adjacent, it is T cos 30 and other one must be T sin 30. So like this you have to resolve that vector torque into its components, sin and cos components. Okay. So it means that this is nothing but T sin 30 and here it is T cos 30 like this. Okay, my dear children. So now I am coming back to this. So this torque is acting as per the given question. It is at a distance of 60 centimeters From here to here it is how much? Distance of 60 centimeters from point C. So now I have to show you that. So 60, since up to here it is 50, let me take up to this point. Up to this point it is 60 centimeters. Up to this point it is 60 centimeters. Okay. 60 centimeters, this one. Like this. So this T sine that is acting in upward direction. So here I have to take this component of tension in upward direction. Look, my dear children, now we are having three components. One is T sine 30, and another one is 20 Newton, another one is 80 Newton. Like this, you are having three different forces. So now what you have to do is that you have to form the torque equation because of these three forces. What is the form of a torque? Force into perpendicular distance. Here the upward force is T sine 30. So here the torque obtained is in anticlockwise direction. And remaining 20 and 80 are in downwards. It is in clockwise. So we people know that as per the torque equation, what you know? Torque balancing equation, what do we know? Torque in clockwise must be equal to torque in anti-clockwise. Like this we have to write. Okay? You know it? Now, so because of T's torque is, what is the formula for torque? As I told you earlier, it is force into perpendicular distance. Now this torque here, it is T sine 30. This is force and perpendicular distance. Children, perpendicular is what? Here T sine 30 is in upward direction, right? So y-axis. So look from C. So up to here it is perpendicular distance. So what is the perpendicular distance? From point C it is 60 centimeters. So let me write it as, here the force is T sine 30 and its perpendicular distance is 60. Over. The first component of force is over. Upward force. Now coming to the downward. It is 20 Newton and 18 Newton. 20 and 18 Newton. Observe this carefully. This 20 Newton perpendicular distance is 50. So let me write this one as this 20 Newton perpendicular distance is 50 plus other downward force is 80 Newton. So what is 80 Newton perpendicular distance here? From C, we have to take the entire length of the rod, that is 100. So here 80 into 100. Understand now? Force into perpendicular distance. Now you just solve this. So 20 into 50, that is 1000. Okay, 80 into 100, that is 8000, which is equal to 9000. Whereas coming to this one, T sine 30. Sine 30 is nothing but half into 60. So you can write this as 30. So this 0, 0 come cancel and 3 and 900. So you can write it as 300. So now the obtained torque T is equal to 300 newtons. What is the obtained tension is 300 newtons. Now look at the question carefully. What did he ask you? What did he ask you? He is asking the tension in the cable. The tension in the cable. This one. Tension in the cable. So you also got the tension in the cable as 300 Newton. So what is the answer now? Option 3. Option 3 is our answer. So the tension in the cable is 300 Newton. Okay. So now let me move on to the next one. So here it is option 3. So now let us move on to the next question.